Calculus video 62, L'Hopital's rule examples 3, or probably better titled, L'Hopital's rule for any type of problem that has like an x to the power of x, a variable in the base and a variable in the exponent. All right, so some examples of this would be the limit as x goes to 0 of x to the power of x. All right, so you've got a 0 raised to a power of 0, or not actually 0 itself, but x approaching 0 to the power of x approaching 0. What is that? What is 0 to the power of 0? I mean, 0 times itself, lots of times, would be 0, but anything to the power of 0 is 1. So what do you get? Okay? Or the limit as x goes to 0 of x to the 1 over x. I'm sorry, the limit as x goes to infinity of x to the 1 over x. That would be like infinity to the power of 1 over infinity. Well, 1 over infinity is 0. Well, what is infinity to the 0? I don't know. Let's find out. Or in this case here, the limit as x goes to infinity of 1 plus 1 over x to the x. So 1 over x is like 1 divided by infinity. 1 divided by infinity goes to 0. And 1 plus 0 is 1. It's not really 1. It's 1 plus a smidge to the power of infinity, right, as x goes to infinity. So what is 1 times itself? Well, 1 times itself is 1, but what if you do it enough times and it's not really just 1, it's approaching 1? What do you get as an answer? So these are indeterminate forms. But they're not 0 over 0 or infinity over infinity. So I can't at this point use L'Hopital's rule, but I have an even bigger problem. My bigger problem is that I have a variable in the base, x, and a variable in the exponent. What do you do with that? Okay, so let's try an example here. Let's do the second one I had up there. The limit as x goes to infinity of x to the 1 over x. And again, this is, if I plugged in direct substitution, infinity to the power of 0. That's not going to work. Well, maybe it's fine, but we can't use L'Hopital's rule. So what we need to do is we need to rearrange this somehow to become the limit as x goes to infinity of some function f of x over g of x that is either equal to 0 over 0 or infinity over infinity. Then I can use L'Hopital's rule, and hopefully everything will be fine. But I've got this x to the power of 1 over x. How do I get it into this fraction form? Well, it would be great if I could take that 1 over x power and, say, bring it out in front of the function, so it's not as in the exponent anymore. But the only way to do that is if you had like a natural log. Or if the natural log, recall, the natural log of, say, x cubed, we can take the cube, we can walk it out in front of the natural log, and that is 3 natural log of x. That's what I want to do with the 1 over x. I want to bring it out in front, but I have to first introduce a natural log in here. So whenever you have an x to the power of something involving x, the way we do this is we start by let y equal this limit. This limit, x goes to infinity of x to the 1 over x. We let y equal the limit. Okay? And then in order to introduce a natural log, because I let y equal this, now I can take the natural log of both sides. If I have two things that are equal, the natural log of those two things are still equal. It's why I need a left-hand side on the equal sign over here so I can introduce a natural log to both sides. So if y equals the limit as x goes to infinity of x to the 1 over x, then the natural log of y is equal to the natural log of the limit as x goes to infinity of x to the 1 over x. And then we get this great property about limits, in that the natural log of the limit is the same as the limit of the natural log. And so from here, we get the natural log of y is equal to, and basically the limit and natural log switch places. It's a property of limits. the limit as x goes to infinity of the natural log of x to the 1 over x. And now I can take this 1 over x and I can walk it out in front of the natural log. So I get this. The natural log of y is equal to the limit as x goes to infinity of 1 over x times the natural log of x. And we're getting closer. If I were to plug in infinity now, I would get 1 over infinity, that's 0. Natural log of infinity is infinity, right? So I've got 0 times infinity still. However, I could rewrite this. Instead of saying 1 over x times the natural log of x, I get this. Notice I'm writing the natural log of y every time here. The natural log of y is equal to the limit, as x goes to infinity, of the natural log of x over x. Right? 1 over x times the natural log of x, that's the same thing as natural log of x over x. Now what happens when you plug in x goes to infinity? You get the natural log of infinity, which is infinity, and then x goes to infinity, that's infinity. Now we can use L'Hopital's rule. So we're not done, but I'll give you a quick recap. Anytime we have a variable to a power variable, we let y equal that whole limit. We take the natural log of both sides. Instead of the natural log of the limit, we can do the limit of the natural log. We take the exponent, we walk it out in front of the natural log, and then we rearrange that so that it's an f of x over g of x with the, hopefully we'll get infinity over infinity or 0 over 0. Okay. Now L'Hopital's rule says this. The natural log of y is the limit as x goes to infinity of the derivative of each of these. So that's the derivative of natural log of x is 1 over x, the derivative of x is 1. Now let x go to infinity, and we get 1 over infinity, which is 0. Be careful. Don't tell me the answer is 0 here. The answer is not 0. Remember that what we wanted was the limit as x goes to infinity of x to the 1 over x, which we called y. So if we solve for y, we've solved for our limit. But we don't have y anymore. This is one of the reasons why I kept writing natural log of y every time. The natural log of y is 0. That doesn't mean y is 0. It means the natural log of y is 0. What we want to do to get rid of the natural log is take e to the power of both sides. E to the natural log of y is y, and e, which is a number, raised to the power of 0, is 1, and since y is equal to 1, that means our limit is equal to 1. The answer here is 1. And in this particular case, infinity to the power of 0 is 1. All right, let's do one more. How about number 2, the limit as x goes to infinity of 1 plus 1 over x to the power of x. All right, so we've got, if I plug in direct substitution, I've got 1 plus 0 to the infinity. That's 1 to the infinity. That is indeterminate form, but not the indeterminate form we need. All right, we want 0 over 0 or infinity over infinity. So once again, we see that I have a variable x. It's 1 plus 1 over x, so there's some variable x in there raised to the variable x. That tells me that I want to do this. Let y equals this limit. Because what I'm trying to do is get that exponent x out of the exponent. I want to bring it out in front. Therefore, I will take the natural log of both sides. Since y is equal to the limit as x goes to infinity of 1 plus 1 over x to the x, the natural log of y is equal to the natural log of that limit. Okay. And by properties of logarithms, the natural log of y is equal to the limit of the logarithm. Right, so instead of the natural log of the limit, we can do the limit of the natural log. Now I have in here, I have the natural log of 1 plus 1 over x to the x. That means I can take the exponent of x and I can bring it out in front of the natural log. And we get the natural log of y is equal to the limit as x goes to infinity of x times the natural log of 1 plus 1 over x. Now if I let x go to infinity, this is equal to infinity times the natural log of 1. Well, the natural log of 1 is 0. This is still infinity times 0. That's still indeterminate form, but I'm a whole lot closer now because I don't have that exponent of x. What I'm going to do is I'm going to take the x that's right here, and I'm going to rewrite that in the denominator as 1 over x. So I have the natural log of y is the limit as x goes to infinity of the natural log of 1 plus 1 over x over 1 over x. Right? So dividing by 1 over x is the same thing as multiplying by x. I haven't changed anything. Now when I let x go to infinity, I get the natural log of 1 over 0, which is 0 over 0. Now we can use L'Hopital's rule. So we're going to take the derivative from this form right here. The natural log of y is equal to the limit as x goes to infinity. And the limit is the same thing. So the property we're using here is the limit as x goes to a of f of x over g of x is equal to the limit as x goes to a of f prime of x over g prime of x. So we don't need to take the derivative of the left-hand side here because those limits are, in fact, equal to each other. All right, so the derivative of the top, so that's the natural log of 1 plus 1 over x. All right, let's do u prime. U prime would be the derivative of 1 plus 1 over x. Derivative of 1 is 0. The derivative of 1 over x is negative 1 over x squared over u, 1 plus 1 over x. Divided by the derivative of 1 over x, negative 1 over x squared. Okay, let's see if we can simplify this. We have the natural log of y is equal to the limit as x goes to infinity. I have negative 1 over x squared divided by 1 plus 1 over x divided by negative 1 over x squared. So instead, let's do this. Let's write negative 1 over x squared over 1. Okay, so I'm dividing like this fraction by this negative 1 over x squared over 1 fraction. So instead of dividing by negative 1 over x squared over 1, I'm going to multiply by 1 over negative 1 over x squared. Right, I'm basically reciprocating that part right there. And I did that because we can see that on the numerator here I have negative 1 over x squared, denominator negative 1 over x squared, those cancel. This is equal to the limit as x goes to infinity of 1 over 1 plus 1 over x. Letting x go to infinity, I have the natural log of y is equal to 1 over 1 plus 1 over infinity. That's 1 over 1 plus 0. That is 1 over 1. That's 1. Please don't tell me that 1 is the answer. The natural log of y is equal to 1, but what we wanted is y, right? So we're going to take e to the power of both sides. E to the natural log of y is just y, and e to the 1 is e. And we see that our answer here is e. In fact, you may have learned this back in algebra, that e is equal to 1 plus 1 over x to the power of x as x goes to infinity. And we have just shown that using L'Hopital's rule.